Hey, look, another day, another lesson. We're going to be describing some distributions using the mean and MAD. Essentially, what this means is we're going to be describing its variability. What is this data going to look like after we have plotted it? Up here is one of the problems that you had from yesterday talking about Sabrina's pets. And it gives you that the mean, remember, was 3 and the MAD on average is 2.2. I want to clarify what this MAD really means because yes, you want it low. Because what this means that if the mean is 3, that means on average, each data point is 2.2 spots away from 3. Well, if this MAD was 14, that means every data point is on average 14 spots away from the mean. That's a lot of distance from the mean. So you want this number to be smaller. The smaller the MAD, the more clustered the data, and the lower the variability. So now I'm going to walk you through how to describe this data. So it says, suppose that the weights of 7 middle school students' backpacks are given below. Fill in the following table. Well, remember from yesterday, the first step that we had to do was calculate the mean. But when we see data points and it's every single one is the same, that's your mean. So our mean is 18. All right? Because they're all the same. So that means the deviation from 18 is 0, 0, 0, 0, 0, 0, 0. And our absolute deviation is the same thing. Now we need to ask ourselves, what's this gonna look like? So it says draw a dot plot. I'm gonna make this really simple. I'm just gonna do 17, 18, 19, well, 7 of them, 1, 2, 3, 4, 5, 6, 7. Then it says, well, we already calculated the mean. That's up there. And it says, what's the MAD? Well, remember that when your data is all above the same spot, your MAD is 0. It's 0. Okay, when it's all over this, remember when we did city A, it's 0. So now going on to number C, it says describe the distribution of weights of backpacks and discuss the center, the spread, and the shape. Well, the center means it's mean. The mean is 18. That's our center of data. What is its spread? What's the spread? Well, there is no spread. No spread, which means there's no variability. Yesterday, I got you into the habit of thinking that 0 is the low variability because I wanted you to realize that the lower the number, the lower the variability. But when you actually have an MAD of 0, you have no variability. There's nothing else around here. And another thing that we want to talk about is that all data points are equal. All right? Now we're going to build on this concept of this data. Okay? So it says, now suppose that the weight of Alicia's backpack is 17 pounds rather than 18 pounds. So we would be taking Alicia's and we would be changing that to 17. We're going to draw a dot plot for that. So if we have 17, 18, 19, now we only have 6 dots over 18 and 1 dot over 17. Now, without doing any calculations, how is the mean affected by this lighter weight? Well, right now, the mean is all the same. It's all the same. But what would it be if you added 1 dot in a lesser value? Would it be the same, or would the new mean be the same, smaller, or larger? Well, it cannot be the same. The only way that it's the same if it's all the same numbers, or if we're balancing it out. Well, since we're giving a data point that's 1 less, our new mean is going to be smaller because of the smaller weight. Just like it would be bigger if we had added 1 in 19 instead. Now think about it. Without doing any calculations, how is the MAD affected by the lighter weight? Would the MAD be the same, smaller, or larger? The only way that the MAD is 0 is if you have all of the data points above itself. So it naturally has to be larger. It has to, because now there's variability. It's still going to be low, but there's still variability. Building on that again, it says, suppose that now Alicia's backpack weight have changed to from 18 to 17, just like up here. And Fred's backpack, whoa, has now changed from 18 to 19. So not only has Alicia's changed, she's lost some stuff in her backpack, but Fred's gained some stuff. Maybe he came and picked it up along the way. So I'm going to draw that dot plot. Here's Alicia's dot, here's Fred's dot, and here are our other 5 students, okay? Without doing any calculation, would the new mean how would the new mean compare to the original mean? Well, the really cool thing about this is that when you balance it out on the side, it's like it's canceling each other out. So it's like if we took this, we crossed it off, what's the new mean? The new mean is 18. It's the same because it's balancing it out. We're able to cross it off. Without doing any calculations, would the MAD for the new distribution be the same, smaller than or larger than the original MAD? Well, remember, we cannot have a MAD of 0 unless all of the data points are along the same point. So no matter what, it's going to be larger than the original. It's going to be larger. And now it says, without doing any calculation, how would the MAD for the new distribution compare to the one here? So how would this one compare and this one compare for MAD? Well, there's more variability in this one. Even though if you don't truly believe it, there is, because now there's one below and above. There's more variability, which means a higher MAD. All right, this similar concept is provided down below. I want you to complete exercise 4 on your own. This is going to be checked. Then I want you to skip over the rest of it, and I would like you to do your exit ticket after you've gotten that exercise 4 checked. After you've done your exit ticket, you are going to do every single problem in your homework. All right, get started.